Tell me about a time you found the root cause of an issue. Introduction. This is one of the most important behavioral interview questions for software developers. Interviewers ask this question to understand how you investigate problems, how you avoid guessing, how you use logs, metrics, and data, how you reproduce issues, how you isolate the real cause, how you validate your findings, how you prevent the issue from happening again. This question is especially important for check Java developers, check backend developers, check full stack developers, check senior software developers, check production support developers, check site reliability engineers, check team leads. The best way to answer this question is by using the STAR method. STAR means S, situation, explain the background. T, task, explain your responsibility. A, action, explain what you personally did. R, result, explain the final outcome. A good interview answer usually spends 10% situation, 10% task, 60% action, 20% result. The most important part is the action section, because interviewers want to understand how you found the root cause, not just how you fix the issue. Question. Tell me about a time you found the root cause of an issue. Example 1. Root cause of slow API response situation. In one production application, users reported that an important API became very slow during peak business hours. The response time increased from under 1 second to more than 10 seconds. Task. I was responsible for finding the root cause of the slowdown and helping implement a safe fix. Action. I started by checking monitoring dashboards to understand when the slowdown started and how often it happened. Then I reviewed application logs, API response time metrics, and database query timings. I compared fast requests and slow requests to identify the difference. After analyzing the traces, I found that most of the delay was happening in the database layer. I reviewed the database execution plan and found that one query was performing a full table scan on a large table. The query was also joining multiple tables and fetching more data than needed. To confirm the root cause, I tested the query with production-like data and compared execution time before and after adding a proper index. Once confirmed, I worked with the database team to add the index and optimize the query. I also added monitoring for the API response time and query execution time. Result. The root cause was confirmed as an inefficient database query. After the fix, API response time improved from more than 10 seconds to under 2 seconds. The system became more stable during peak traffic, and the team used the same analysis approach for other performance issues. Why this answer works? This answer is strong because it shows check systematic investigation, logs and metrics analysis, database execution plan review, root cause validation, measurable improvement, production impact. Example 2. Root cause of intermittent login failure situation. After a production release, some users reported that they could not log in. The issue was difficult because not all users were affected. Task. I was responsible for identifying the root cause and restoring normal login behavior. Action. I started by reviewing authentication logs and recent deployment changes. Then I compared successful login attempts with failed login attempts. I noticed that failed users all had a specific role. This helped narrow the issue from a general login problem to a role-based access problem. I reviewed the Spring security configuration and found that one endpoint required during login was accidentally restricted for that role. The login process started correctly, but token validation failed because the endpoint was blocked by the new security rule. To validate the root cause, I reproduced the issue using a test account with the same role. Then I updated the authorization rule and tested login scenarios for multiple roles. I also added automated tests for role-based login and access behavior. Result. The root cause was identified as an incorrect Spring security authorization rule. The login issue was resolved quickly. Affected users were able to access the system again, and the new tests reduced the risk of similar security issues in future releases. Why this answer works. This answer is good because it shows pattern identification, role-based debugging, Spring security knowledge, reproduction, validation, regression prevention. Example 3. Root cause of duplicate record situation. In one application, users occasionally saw duplicate records created for the same request. The issue did not happen every time, so it was difficult to reproduce. Task. I was responsible for finding the root cause and preventing duplicate records from being created. Action. I started by reviewing duplicate records in the database. I compared timestamps, request IDs, user IDs, and business keys. I noticed that duplicate records had almost identical timestamps, which suggested that multiple requests were being processed at nearly the same time. Then, I reviewed application logs and found that some users were clicking the submit button multiple times quickly. I also reproduced the issue by sending concurrent requests to the same endpoint. The backend logic checked whether a record already existed before inserting a new one. However, two requests could pass the existence check at the same time and both insert records. This confirmed that the root cause was a race condition. To fix it, I added a database-level unique constraint on the business key and updated the service logic to handle duplicate insert attempts gracefully. I also updated the frontend to disable the submit button after the first click. Result: the root cause was confirmed as a concurrency issue. Duplicate records were prevented. The fix improved data integrity and made the system safer under concurrent requests. Why this answer works. This answer is strong because it shows: check. Data analysis, concurrency investigation, check. Race condition identification, check. Database constraint usage, check. Front-end and back-end fix, check. Data integrity improvement. Example 4. Root cause of incorrect report total situation. The business team reported that daily report totals were incorrect for some dates. The issue was serious because the reports were used for business decision-making. Task. I was responsible for identifying the root cause of the mismatch and fixing the reporting logic. Action. I started by comparing the report totals with source transaction records. Then, I reviewed the API response, SQL query, aggregation logic, and date filters. I noticed that the mismatch happened mostly for transactions created near midnight. That pattern suggested a possible time zone issue. After deeper investigation, I found that the transactions were stored in UTC, but the report was grouping data using a different time zone conversion than the business expected. Some transactions were being counted under the wrong business date. To validate the root cause, I created test cases using transactions near midnight and compared the expected business date with the actual report date. Then I updated the date conversion logic to use the official business time zone consistently. I also added test cases for transactions near midnight, month-end dates, daylight saving time changes, UTC to local time zone conversion, date range filtering. Result: the root cause was identified as inconsistent time zone conversion. After the fix, the report totals became accurate. The business team regained confidence in the reports, and the new tests helped prevent future date-related issues. Why this answer works. This answer is good because it shows data validation, SQL investigation, pattern recognition, time zone debugging, business impact awareness, edge case testing. Example 5. Root cause of Kafka consumer lag situation. In one event-driven system, downstream updates were delayed. The API was working correctly, but customer updates were not reaching another system on time. I was responsible for identifying the root cause of the delay and restoring normal message processing. Action. I started by reviewing Kafka consumer lag metrics and application logs. I found that lag was increasing on one specific topic. Then, I checked failed message logs and noticed that the consumer was repeatedly failing on a few messages. Those messages had an unexpected data format. Because the consumer kept retrying the same invalid messages, valid messages behind them were also delayed. To confirm the root cause, I replayed one of the failed messages in a lower environment and reproduced the failure. Then I updated the consumer error handling. I separated retriable errors from non-retriable errors. Invalid messages were moved to a dead letter queue instead of blocking the main consumer flow. I also added monitoring for consumer lag, failed message count, retry count, dead letter queue messages, processing time. Result: the root cause was identified as invalid messages blocking the Kafka consumer. After the fix, consumer lag returned to normal. Valid messages were processed on time, and invalid messages were isolated for later review. Why this answer works? This answer is strong for backend interviews because it shows Kafka debugging, consumer lag analysis, message replay, root cause confirmation, dead letter queue usage, production reliability. Example 6. Root cause of batch job failure situation. A nightly batch job failed intermittently in production. The same job passed on most days, but failed when certain input files were processed. Task: I was responsible for finding the root cause and making the batch job more reliable. Action: I started by reviewing batch logs, failed step details, input files, and database records. I compared successful input files with failed input files. After comparison, I found that the failed files had a few records with an older legacy format. The batch processor expected the new format only, so it failed when it encountered the legacy format. To validate the root cause, I created a small test file with the same legacy format and reproduced the failure in a lower environment. Then I updated the parser to support both the current and legacy formats. I also improved validation and error reporting, so invalid records would show clear error messages. I added tests for current format, invalid format, missing fields, restart scenarios. Result: the root cause was identified as unsupported legacy input format. The batch job became stable and processed both formats correctly. Future failures became easier to diagnose because the error messages were clearer. Why this answer works? This answer is strong because it shows batch debugging, file comparison, legacy compatibility, reproduction, validation, production reliability. Example 7. Root cause of memory growth situation. One Java microservice started showing high memory usage in production. The service did not fail immediately, but memory alerts were triggered regularly during peak traffic. Task: I was responsible for finding the root cause of the memory growth and improving service stability. Action: I started by reviewing memory metrics, garbage collection logs, and container resource usage. I noticed that memory usage increased gradually over time and did not return to normal after traffic decreased. This suggested that some objects were being retained longer than expected. I collected a heap dump and analyzed object allocation. After analysis, I found that an in-memory cache was growing continuously because it did not have an eviction policy. The cache stored lookup data, but old entries were never removed. To validate the root cause, I reproduced the pattern in a lower environment by simulating repeated requests. Then I replaced the unbounded cache with a controlled cache strategy. I added check, maximum cache size, time-based eviction, cache hit rate monitoring, memory monitoring, alerts for abnormal growth. Result: the root cause was identified as an unbounded in-memory cache. After the fix, memory usage became stable during peak traffic. The number of memory alerts dropped significantly, and the service became more reliable. Why this answer works? This answer is good because it shows check JVM troubleshooting, check memory metrics analysis, check heap dump investigation, check cache issue identification, check validation, check production stability. Example 8. Root cause of frontend stale data situation. Users reported that after saving changes on a page, the old data still appeared on the screen. The save operation seemed successful, but the UI did not always show the latest value. Task: as a full-stack developer, I was responsible for finding whether the root cause was in the frontend, backend API, or database. Action. I started by reproducing the issue using browser developer tools. I checked the Network tab and confirmed that the Save API call was successful. Then, I checked the backend logs and database record. The database had the updated value, which showed that the backend was saving correctly. Next, I reviewed the frontend state management. I found that after saving, the page was still showing old data from local state instead of refreshing from the API or updating the state correctly. To validate the root cause, I manually refreshed the page and confirmed that the latest data appeared. Then, I updated the frontend flow so that after a successful save, the state was updated correctly and the latest data was displayed. I also added clear success and error handling. Result. The root cause was identified as stale frontend state. After the fix, users saw updated data immediately after saving. Support tickets related to this issue decreased. Why this answer works. This answer is strong for full-stack interviews because it shows: check front-end back-end isolation, check API verification, check database verification, check state management debugging, check user experience improvement. Best short answer version. If you need a short interview answer, you can say, in one production application, users reported that an API became very slow during peak business hours. The response time increased from under 1 second to more than 10 seconds. I was responsible for finding the root cause and helping implement a safe fix. I started by checking monitoring dashboards, application logs, API metrics, and database query timings. I compared fast requests and slow requests and found that most of the delay was happening in the database layer. Then, I reviewed the database execution plan and found that one query was performing a full table scan on a large table. To confirm the root cause, I tested the query with production-like data and compared execution time before and after indexing. After confirming the issue, I worked with the database team to add the correct index and optimize the query. As a result, API response time improved from more than 10 seconds to under 2 seconds, and the system became more stable during peak traffic. Common mistakes to avoid. 1. Jumping to a solution too quickly. Bad answer. I thought the database was slow, so I added an index. Better answer. I checked logs, metrics, traces, and execution plans to confirm the database query was the actual bottleneck. 2. Not explaining how you confirmed root cause. Bad answer. The root cause was a slow query. Better answer. I confirmed the root cause by testing the query with production-like data and comparing execution time before and after optimization. 3. Only describing the fix. Bad answer. I fixed the issue by updating the code. Better answer. Explain how you investigated, isolated, confirmed, and then fixed the issue. 4. Ignoring evidence. Bad answer. I guessed it was a back-end issue. Better answer. I compared front-end behavior, API response, back-end logs, and database data to isolate the issue. 5. No prevention step. Bad answer. The issue was fixed. Better answer. I added tests and monitoring to prevent or detect similar issues earlier. Best practices for answering this question. C. Use the STAR method. Explain the symptoms clearly. Show how you gathered evidence. Compare successful and failed cases. Reproduce the issue when possible. Isolate the failing layer. Confirm the root cause before fixing. Explain the fix clearly. Mention testing and validation. Add prevention steps. Measurable results. What interviewers are looking for. Interviewers want to see whether you can cross-investigate systematically, cross-avoid assumptions, cross-use data and evidence, cross-isolate the real issue, cross-reproduce problems, cross-validate root cause, cross-communicate clearly, cross-fix issues safely, prevent repeat problems. For senior roles, they also want to see: check ownership, incident analysis, cross-team collaboration, production thinking, long-term prevention, mentoring others in debugging approach. Strong words to use in your answer. You can use words like check, investigated, analyzed, compared, isolated, reproduced, confirmed, validated, traced, measured, identified, resolved, prevented. Example: I analyzed the logs, compared successful and failed requests, isolated the issue to the database layer, confirmed the root cause using the execution plan, implemented the fix, and validated the improvement with performance testing. Good example topics you can use. Depending on your experience, you can talk about slow API response, login failure, duplicate records, incorrect report totals, Kafka consumer lag, batch job failure, Java memory growth, frontend stale data, API timeout, database deadlock, wrong data mapping, validation failure, deployment configuration issue. Final summary. Tell me about a time you found the root cause of an issue is an important interview question for software developers. The best answer should include what issue happened, why it mattered, your responsibility, what evidence you checked, how you isolated the issue, how you confirmed the root cause, what fix was applied, what result you achieved, how you prevented recurrence. Good examples include slow API response, slow intermittent login failure, slow duplicate records, slow incorrect report totals, Kafka consumer lag, slow batch job failure, memory growth, front-end stale data. The strongest answers show systematic investigation, evidence-based thinking, clear root cause, and measurable impact.